I'm going to walk through some of the key points in Chapter 3 and provide some additional resources to help clarify some of this stuff. And we're going to skip over about half of the chapter, I think, too. So let's get started. So Chapter 3 talks about interfaces and what interfaces are. You should have covered interfaces in Java 2. If you want a good review of Java and interfaces, in the learning resources, I have this review from the University of Utah that just kind of walks through simple interfaces in Java. So you might want to review that. But we're starting at pretty basic level here anyway. So in C Sharp, we define an interface. So an interface is really just a contract or a set of methods that you have to a class has to define. We don't instantiate interfaces. We just say that objects subscribe to them or implement them in some ways. So here's how we define an interface. We say public interface and then the interface name. Often interfaces start with a capital I, but not always, depending on naming conventions. And then again, we define some methods that we are defining here. So usually the interface is just a set of methods. These are kind of abstract methods. They have no definition, so they just short circuit with a semicolon here. So we have a set of methods with parameters that are needed for this interface. Now in C Sharp, you can also include properties here and event handlers. So we'll look at now. Let's open this up. They have code here. I'm going to open that up in C Sharp. I've posted the source code to here. This chapter 3 example has this also in it, with some other small changes. So let's first look at the interface. Again, a method. They show both a property, a string property with a getter and a setter, and a integer property just with a get, and an event handler here that we have. We won't talk too much about event handlers right yet, but now if we're going to implement this simple interface, we have this simple interface implementation. So this is a class, and just like inheritance where you have specify a parent class, here you can specify an interface, so same sort of way, but again, hopefully this interface might start with a little I to give you a hint. Otherwise you're just going to have to look here and see that what we're implementing here is an interface and not a class. Okay, so we see this is a class, this interface. So what that means is that this interface, this sorry this class, the book called it Simple Interface Implementation, has to implement all of these things here. So now, if this is blank, well, if one of these is missing, for example, you should get an error here underlining here, and the suggestion will be to implement the interface. If you choose this, it'll stick in a blank version here. It's going to stick it down at the bottom. I'm going to move that back up to the top here, but it'll put the interface implementations in for you, but they'll be empty except for this throws the non-implemented exception. You want to then put something in here. So in this case, we're just going to put in a simple console.writeLine and say something. So we're doing something in this interface. Okay, so we have to implement all the methods here. We also have to implement any properties. This is kind of strange. Usually in interfaces we don't allow attributes or fields, but C# does allow properties, which is kind of strange. But we do have to redefine those here as a property and set the getters and setters as needed. Now, even though like the interface might just specify a getter, we generally have to specify both a getter or a setter for properties here, so we can actually set its value and get its value. And again, you might have an integer here, an event handler here that you have to do. And you might have your own local variables in your class and whatever. This will be just some part of your class that you'll have to implement. Now let's look at how we might use this class in the main program. So again, we're kind of following along here. They walk you through the simple interface and the simple interface implementation here, but they don't show you how to use this in the main program. So I've added that here. In the main program, we can declare an object of this simple interface implementation here. I'm just calling it S and call the constructor here, and then we can call use S and call the different methods or set the properties of that are in this area. So we can call this method. We can this string needs to be an implementation too. We can set that string. This integer property only needs a getter. So we can call kind of strange names they use for these things, but we can assign these properties values and stuff like that. Now, that one of the powers of interfaces is not to define an object of this class, but to define an object, declare an object of the interface. Let's see how we kind of do that. So we can say I simple interface, simple interface I equals new. And then here we don't specify the interface, but the implementation. So we specify the class, because we have to. The interface itself doesn't have a constructor, but the class does. But we're creating this class, but we're looking at it in terms of this interface. And then we can call methods in this here. Now it's interesting. Now the interface only specifies a getter and not a setter for this integer property. And so here, when we're trying to set the integer property to some value 7, while that is defined in the object, it's not defined in the interface, and so we are not allowed to do that here. We get this error. I'm just going to comment that out. Okay, so let's look at another example of an interface. So where we might see this a lot is when we have a collection of different objects that all have to behave the same. I'm teaching a game design class, and so for example, we might have different objects you have in your game that all have to be added to the inventory. So we'd have an inventory interface that would implement some methods like add inventory or display icon in inventory or remove from inventory or stuff like that. And so your objects would have to do that, implement that interface, those methods, and then it allows you to put a number of different types of objects into an inventory. Similarly, let's say you're working for some place like Amazon and you have a whole bunch of different items you want to sell, and you want them all billable on the same area. So we might create a billable items interface. So this is a public interface called billable item. So for every billable item, we need to be able to print its description, get its cost, and calculate its shipping weight. So we specify that interface, billable items. And then maybe we have different items. Maybe we have books, third-party items, who knows what. But here's just one. So we have a book, and it's going to implement a billable item. So here's our book, a constructor, a new title, new author, and a new weight. We specify. Books have titles, they have authors, and they have a weight. We have a shipping weight here that we have. So to implement this interface, we need to make sure we're implementing print description. So our book should have a print description. This is a book by. It should have a get cost. Here's the get cost. It just returns a cost. We might have a cost variable up here that we'd store, and we might just return that as one option, but here we're just returning a number. Now, one thing to note that dollar amounts in C# should be stored as decimal, a special type created largely for this rather than a float or a double. And then when you specify constant, if you want it to be a decimal, you have to say an M after it as the suffix. Okay, so that gets the cost. And then what else? Oh, the shipping weight. We need a getter and a setter for that attribute. So here's a shipping weight and a getter and a setter. And again, it's got a weight built into it, and it's just returning that weight or allowing that weight to be set. Okay, so book implements this interface. So then our main program, we can declare a book and do a new construction. But we can call print bill and pass the book there. But print bill is not set up to work with books, but any billable item. So print bill is this method down here. It will take any billable item. So this is an interface and call its item. And then so here we'll only call methods defined in this interface here. So we can say item purchase and we can say item.print description because that's defined in this interface. Or we could also print its cost if we wanted. So we can use this. And what's cool now is that this book can be passed to a method that takes a billable item, takes an interface. And again, we'll use this a lot. So we can use kind of polymorphism where we can have multiple objects, different types of objects mapped into the same interface, and we can like declare methods that will use that interface. So interfaces are used a lot, and we'll look at a number of patterns coming up that will use those. Okay, that's our review of interfaces. We go into some things with multiple interfaces, how you can specify multiple interfaces, and the book talks about problems with multiple inheritance. When you have two parent classes, that has problems, and so you're not allowed to do two parent classes for this. There's a lot of discussion on when you should use inheritance, a parent class, and when you should use interface. And nowadays we use interfaces a lot to specify some contracts, and it's very common for for classes to be implementing more than one interface. For example, a recent game we were working on, game design class, on objects like a sword object, implement both the inventory interface, so it could be put in inventory, and the weapon interface, so it could be used as a weapon. And then we have methods that rely on both. So, okay. Now, there's explicit implementation of interfaces. We're going to skip over this whole section on explicit implementations. They're not used that much, and when you do, if you do need to know them, you can look back. But usually there's a clash between the name in the interface and some other name you can't change in your method or parent method or something like that. So we're just going to skip over explicit implementation. Polymorphism we just talked about just a little bit is that we can define an interface like a vehicle interface, and we can have cars, motorcycles, speedboats, all implementing that interface, and then we can have methods that we can declare an array or a list of these vehicles, and we can put all of these things in that array. We can have methods that require a parameter of this type, and any of these things can be passed. So kind of imagine interfaces again are a way of wrapping a costume around an object so it appears as a different way. So we can take car, wrap it up in put an iVehicle interface on it, and then the car can pretend to be an iVehicle whenever it needs to. Okay, now we're going to get into some patterns. So design patterns were proposed, first came in popularity about 1994, about 20 years ago, and they're still quite popular now, and there are quite a few common patterns. These are ways of implementing software that have proven to be very useful and repeatable. So we'll look at a number of patterns. In fact, the rest of the course is largely focused on different types of patterns. So we're going to look at just a couple patterns today in this chapter that make use of interfaces, because we just learned what interfaces are. So the first one is this null pattern interface. So it's not uncommon when you're declaring an object, or maybe you're getting an object from some location. You're calling some procedure supposed to return to you an object, but sometimes something go wrong. Return null. It won't return anything. And then when you try to use that object, here we have a user, and then use this dot and try to reference something, you'll get a null reference exception error, and your program will crash. So instead, often when you're using this, you've got to be checking if if your object is null, and if so, refer to this. Now this might not look like too bad in this one case, but it can be get complicated. Let's see. Here's some code that I uploaded from a project of ours a number of years ago that was going out to Amazon and pulling all the book lists from Amazon and linking them all together. This is in Visual Basic, and so it's a little different. And in Visual Basic, they don't use the word null. They use the term nothing generally. So I just wanted to show you all the checks for nothing. These are all the checks for null. So this is just a segment of the code that does a lot of checks. So here we're checking if this list array we've grabbed from Amazon is nothing. And then if something in there, now we're checking the first element. And if there's errors, and if that's nothing, then we're going to throw an exception. Okay, if both of those work, now we start checking. So now make sure the list array is not nothing. Then we're going through each element, and then we're checking if each element is nothing. So this is an array of lists. So we're given a list, and so we're grabbing each list now from the array, checking that that's not nothing, and then we're checking it again here. And so now here we're checking each item, making sure each item is not nothing. Each item contains another list of items, and we're checking if that's nothing. And then once we're in there, we're doing some checks on that. So again, you can kind of just see the checks here. We're within an if, another if, another if, another if, another if, another if, all checking if this is all null. So I mean, this is certainly not optimal code, but again, you can see how with complex data types where you have an array with an object in there, and you're trying to parse it all, you can get into very complicated code that's not readable. I mean, this code is not readable at all at this point. So one way to avoid some of that is with this pattern. So rather than having the client access the object directly, the real object directly, we'll have the client implement an interface, and that will specify all the methods we need to access this object here. And then we'll also have a null object, which will also implement these methods, but won't do anything in these methods. And then the client will be given either a real object or a null object. It won't know, it won't care, and it can call all the methods that are defined in its interface. It can call all the methods. In a real object, they'll do something, and in otherwise, it just won't do anything. So it walks you through here, it goes through an example that's creating, here we have an array of users here, and then we're going to try to find a user by ID. So we're finding, we may not know if that's found, so we're checking if it's null here. So this is the implementation of this, where we're checking if it's null once and we're returning the null user. So this interface here is either going to return a null object or a real object to the client for us. So the interface itself checks, does this null object implementation. It checks gets a user ID, and if the user is found, or if the user isn't found, it's going to create a null user. Otherwise, it'll return the user for us. Okay. And again, within the null user, we'll have methods, and they usually just are empty. They do nothing here. So walk through that, and then there's this explanation of this null property. Is null property anti-pattern? An anti-pattern is what the author uses to describe bad practices. So one way of setting this up and using this is inside your classes or your interfaces, define an is null parameter and using that. But if you're using an is null parameter, you're still doing a lot of checks for is null. out there. So we want to avoid those checks. So it just walks through how this is not a good pattern. So we want to try to hide that from here. So we want to put all the checks for is null and stuff in here in the interface. The real objects don't have to worry about is null. There should be no checks for is null in here, and there should be no checks for is null here. The only check should be here, and if there is a problem, it should return a null object back here. So it kind of isolates all the checks for is null into this one interface for us. Okay, now another thing is the cascading nulls. That's what we kind of saw in the earlier sample code I was showing you, is that if there's another null, if the person is null, and then we look inside the person's address if that's null, and then look inside the person's address in their country and see if that's null. This walks through another way of specifying this that's common in a language called Groovy, called cascading nulls. We're not going to really worry about that too much here. Okay, the adapter pattern. We're going to get into this a lot in this week's assignment. So I'll just do a brief introduction to it here, and then we'll do more of it in the assignment. The idea is that you have some client, you're working with you're writing some software, and it has to access some old software, some software you don't have control over. Maybe it's some software that's made by a third party. Maybe it's some software that's made by another group at your company. Maybe it's some software in a different language in a COBOL mainframe or something like that. But you can't control this. You can't change this software. But your whole system is worked with interfaces, and you want this software to implement an interface. Well, you can't change this software, and so you can't have it implement an interface directly. So what you do is you create an adapter class here. This adapter class implements the interface and then calls and creates an object of this adaptee type, this type you can't use. And so your client here can create an adapter which in turn creates one of these, and this will implement the interface, and it will do whatever mapping. This might do some conversions and stuff to convert this interface into this older method here that you can't change. And again, we'll look at this in the assignment for this week, so just walk through this. And there's two ways of implementing the adapter pattern. One's called the class adapter pattern that uses inheritance. We're not going to do this one because and I didn't, and when I explained it I was using this picture, but this one uses inheritance, the class adapter. The more commonly the one I prefer is the object adapter class, which uses this interface, and that's what I described above, but I was just using the wrong picture here. So you have a client and it's supposed to be implementing an interface, and you have some target, some code that doesn't implement that interface. You create an adapter that will implement that interface for you using this target. So and this walks through the code. So again, focus on this object adapter pattern, not the class adapter pattern. We'll prefer the object adapter pattern because we'll be using interfaces more. Okay, last pattern here is the strategy pattern. So sometimes you'll have a couple strategies you want to choose between, and you want to be able to quickly jump between these two methods. So you might have a couple different methods here. So sometimes we do this in a state machine. Our client might change from one state to other, depending on what state will execute things differently or stuff like that. So this is a way of setting up what we call different strategies or different ways of doing things. So we have a client that and then we have an interface, and the client will want to use this interface, and we'll have a couple different strategies. They'll implement all the methods in this interface, and then the client will declare objects of this type and this type, but will declare them and use them in terms of this interface, and will only reference them in terms of this interface. And so it can easily swap between these two objects. Even though these are different objects inside the client, they'll appear to be the same because they'll be defined in this terms of this strategy here. So here's an example. We have a strategy interface. It only has one method called execute. We have strategy A that implements that interface, so here's its version of execute. We have strategy B that implements that interface, and here's its version of execute. And then here's our main class, often called context in these examples. So we will create a strategy A and a strategy B, and we'll call it constructors for strategy A and D, but we'll store these variables as iStrategy variables. So these two variables will basically be the same as far as this is concerned, and so we can switch between these very easily. And so here, like for example, they have the current strategy, and then they're calling strategy A or strategy B, setting some strategy to that. So they have a strategy, a current strategy variable, and sometimes they'll set strategy A to that, and sometimes strategy B. And again, what the power is that even though these are different objects, different classes inside the client, because we're going through this interface, these two will appear the same. We instantiate them, but we store them in variables mapped to through the interface for this. So I have another example that walks you through the strategy pattern here. Walks you through basically that same one here, but also walks you through a robot pattern. I always like robot examples because we do a fair amount of work with robots here. But here we have an aggressive behavior, a defensive behavior, and a normal behavior. They all implement a different version of the move command, and our robot then is implementing this, and then it walks you through this. Now this is not in C# exactly, so the code will be this implement means it's in Volley Visual Basic, but you can see the basic idea here of how this is working, and we're creating robots and doing moves in different ways for this. Okay, so that's the strategy pattern. Now we get into some issues with duck typing, which we're going to skip over. We're going to skip over much of the rest of this chapter. Duck typing is if some code walks like a duck and swims like a duck, quacks like a duck, we can call it a duck. And so, if something does everything an interface does but doesn't say it implements it, can you automatically assign it, and walks you through. Again, this is not this is used in some languages with loose typing, and we're not going to get into this issue in this class. So all this duck typing, the CLR support here, this mix ins, we're not going to get into that. This remotion stuff, we not need to get into that. So we're not going to do any of this duck typing stuff. Again, when we want to implement an interface, we'll just specify that we're going to implement it as an interface. Last thing we'll mention, though, is at the very end of this chapter, fluid interfaces. Sometimes these are called, what are they called again? Method chaining. So what you have is you have methods, and the methods will return the parent object in some ways. So if you have a method, it will return this. It always returns the parent class here. So then, because often we have code that looks like this. We have some object, and we say dot do something, and we use that object again, do something else, and then you call that object again, do something else. This isn't that bad here because the object name is relatively short. Sometimes these references to an object can be very long. We might be saying, this object, and then specifying some list that it's we have an array of that, and then some object in there, and some object. So sometimes this part before the dot can get quite complicated. But now we have this here. If do something returns the object, we can just say do something, and then we can do dot and do something else. So we can do this here, fluent dot do something, no semicolon, dot do something else, dot do something else. And in fact, some people put this all on one line, although I do like this formatting this way, and then there's just a semicolon at the end. So it's a different way of calling a chain of methods all relating to the same object. The requirement is that each of these methods have to return the object itself for this to work. Now some people like this, and some languages rely on this a lot more. again, maybe I'm old school. I don't prefer this. I prefer this whole method like this of setting things up. But again, you'll see this around, and some people prefer it. And I don't necessarily don't know a good argument for not doing this. If you look online, there's lots of discussions about which way people prefer. So just be aware that this is an option out there that you'll see sometimes. Okay. So that wraps up this. I'll have another video that will walk you through the prep for this week's assignment.